of limiting an excess reactant. So this is the part 2 video, and we're going to focus on calculating the mass of excess reactant that was used and the mass of excess reactant that is remaining, meaning it's going to have to go to the trash. It's a waste product. And so you have to have already addressed who was your limiting reactant, who was your excess reactant, and ideally you would have already been aware of how much product you could actually make because of the limiting reactant. So I have that out written to the side, the top right in blue, and I still have the balanced equation. I still have the molar masses that was given to me with this particular problem. And here's how this works. In your second set of calculations, you already know who your limiting reactant is and you know who your excess reactant. You know how much product you're going to make based off your limiting reactant, but now you want to focus on how much excess reactant you used. Remember, excess means you're going to have left over. So you want to find out one of two calculations. How much excess reactant was used? Once you know how much excess reactant was used, you can then calculate how much excess reactant was remaining. So this is two separate calculations. The part that's remaining is the part that's sitting left over on the lab bench. And it's the part that in your mind is going to the trash. It's waste. And so this is again going to be two different calculations. So here's how you begin. To calculate the mass of excess reactant used. So this is your first step. In order to do that, you have to go back and focus on your limiting reactant. You always start with the limiting reactant. And so my limiting reactant in this particular question was my sodium hydroxide, NaOH. And I had to begin with 5.00 grams of NaOH. I'm going to now look at the relationship between sodium hydroxide and CO2. Remember, sodium hydroxide is my limiting reactant, CO2 is my excess reactant. So I'm going to see how many grams of CO2 did I actually use when I mixed it with, when I reacted it with the 5.00 grams of sodium hydroxide. I had 5.00 grams of carbon dioxide available, but remember, that's not how much I used. That's how much was just available to begin with. So you start with your limiting reactant, which is your 5.00 grams of sodium hydroxide. And again, big picture, you're trying to go from grams of sodium hydroxide to grams of carbon dioxide. But right now, you need to get out of grams of sodium hydroxide. And so eventually you want to get into moles of sodium hydroxide, which means that you're going to have to go into molar mass. And so every 1 mole of sodium hydroxide, based on the molar mass given to me here with this problem, that's going to always equal 40 grams. Now I'm out of grams of NaOH and I'm in moles of NaOH. Now I can compare the relationship between my limiting reactant and my excess reactant. And so I'm going to want moles of my limiting reactant, sodium hydroxide, in my denominator, and moles of CO2, my excess reactant, in the numerator, and that will cancel out moles of NaOH. So now I just bring down the coefficients that I have from the balanced equation. So the balanced equation has a 2, and next to CO2 there's nothing, so that means 1 mole. So now I'm in moles of CO2, and I can get to grams of CO2 if I just use molar mass. So again, I'm going to set this up so that I have moles of CO2 in my denominator, and I'm going to have grams of CO2 in my numerator. So right now, from this stoichiometry equation, I was able to look at the relationship between my sodium hydroxide, which was my limiting reactant, so let me label that right here, And I'm going to finish with grams of CO2, which is my excess reactant. So that's what this string equation was looking at. And so once I put all this into the calculator, my calculator gives me a really long decimal value. Never mind, it doesn't. So that's going to end up equaling 2.75 grams of CO2. That's what my calculator says. So remember, I just put in 5 divided by 40 divided by 2 times 44. And I get 2.75. So this right here now, I want to turn into a sig fig answer. And my data based with this question was 3 sig figs. Remember, I had 5.00 grams of each. So my final sig fig answer is 2.75 grams CO2. This right here is the amount of excess reactant used. Okay. Now I need to figure out how much was remaining. So my remaining is always going to be how much was available, and that comes from my data, minus how much was used, and that comes from the calculation that I just performed. And that's going to be now my remaining. And so my data, that comes from the problem. And the problem specifically told me that I had 5.00 grams of CO2. Remember, you're dealing with your excess reactant only here. So it was still 5.00 grams, but it was the CO2. That was our excess reactant. Well, how much excess reactant did we use? This is the part that you really want to make sure you're using your calculation answer. You're not using your sig fig answer. So I'm going to make a note here for you that says calculation answer. Otherwise, remember, you're double rounding, which is not good. So it happened to be that for this particular question, our calculation answer and our sig fig answer was the same. But in the others, you want to make sure you always go back to your calculation answer. So now that I put this into the calculator, or I can just subtract it, I know that my final answer here is 2.25. But remember, I have to do sig figs. So because I'm dealing with subtraction, my sig figs is going to be based off of decimal places. So I have to look at my data only. My data was the 5.00 grams. And remember, 5.00 grams, that was the same for both my limiting reactant and my excess reactant. So both of them have 2 decimal places. So that means I want my final answer to have 2 decimal places. So that means my final answer here is 2.25. The unit is grams of carbon dioxide. So now I have both of my answers. I have the amount of limiting reactant that was used, and I have the amount of, I said limiting reactant. This is the amount of excess reactant used, and this is the amount of excess reactant that was remaining. So when the problem told you that you had 5.00 grams of each, your limiting reactant, your excess reactant, what happened is you used up the entire 5.00 grams of your limiting reactant. In fact, you ran out. You could have used more. Your excess reactant, you started with 5.00 grams of it. You ended up only using the 2.75 grams of it. And that means that your initial amount available, your 5 grams of it, you only used this quantity. This amount right here, 2.25 grams, that's now going to be the remaining. That's the part that goes in the trash.